right now back to our panelists. I'm going to let them introduce themselves, and I will start by Tom tonight.
Hello, everybody. It's really nice to be here, and thanks for having us. Just a bit about myself, firstly. Yeah, I did a PhD, which I finished about a year ago, at the intersection of machine learning and electron microscopy, which is where you scan an electron beam over a bit of metal and examine the crystal structure, orientation, chemistry, and all that sort of stuff. So yeah, I came in from like a sort of computer vision background. And yeah, now I work at Arabesque AI for about a year, starting off with an internship on unsupervised learning of financial time series, which is what we do. And yeah, now I work more on the supervised stuff, so predictive modeling of time series, so things like traditional machine learning and also deep neural networks.
Pretty cool, pretty hard. Yeah, thanks, and we're happy to have you tonight, Tom. Isabel, do you want to introduce yourself?
Sure. Thanks for having us. I think it's a really cool initiative, and thanks, Mike. Yeah, so I'm Isabel. I've been working at Arabesque for the past 2 years, and actually have a bit of an unusual background because before that, I was doing, so I have a humanities background. I was doing a PhD in linguistics, and I was studying how bilingual children learn words. So it was, transitioned quite far from my first domain of expertise, but shows that tech can be inclusive. Anyone can make it. Yeah, and I do use my linguistics background to a certain extent because I work on the NLP side of what we do. So processing language, news, social media data, etc.
I hope there will be a lot of questions on that. Thank you so much and welcome. Simon, do you want to introduce yourself?
Sure. Yeah, I just want to echo the sentiments of thanks everyone for being here tonight with us. It's a great opportunity to speak. So yeah, my name is Simon. I'm currently a quantitative analyst / engineer at Arabesque. I've only been here for 2 months, so I'm pretty fresh. But I'm kind of a bit of the odd one out, I guess. So everybody here, I think, is an AI researcher, but myself sit more with the with the investment portfolio construction. So I'm more than happy to kind of bridge the gap between artificial intelligence and finance. And if anyone's got any questions about finance in particular, I started by doing a master's in electronic engineering. How I got into finance, it's a bit of a random jump, but yeah, I can explain that if anyone's interested. And yeah, I've worked through various financial institutions like HSBC, Fidelity Investments, doing pretty similar stuff. But again, yeah, happy to take any questions on my experience.
That's pretty cool. Thanks, Simon. Yeah, I think there's a lot of career changer in our community, so I'm pretty sure people will have a lot of questions. I am one too. So yeah, Cameron, do you want to introduce yourself?
Sure, thanks, Mike. And yeah, just to echo everyone's sentiment, thank you all for having us this evening. So yeah, hello everyone. Nice to meet you all. I'm Cameron. I've worked as an AI researcher at Arabesque for about almost 2.5 years now. Yeah, working on stuff similar to what Tom mentioned. So basically, at a very high level, we try and predict stock prices in the future. And to do this, we use machine learning techniques, basically, a whole variety of different machine learning techniques. So that's the thing I focus on here. Prior to my time at Arabesque, I worked as a postdoc researcher. So I was in academia at Cambridge, working on statistics, basically. And prior to that, I did my PhD in astrophysics and statistics, also at Cambridge. And then prior to that, I guess vaguely similar to Simon, I have some experience in finance as well. yeah, sort of on the dark side of finance in investment banks and stuff. So yeah, happy to talk about any of my past experiences or anything if people are interested in different routes into finance.
Thank you so much, Cameron. Please, for everyone who joined us, please pop your question in the chat box. I'll be happy to relate those. But I will start with my questions. Actually, I'm quite curious and interested here. But maybe to kind of, I'm going to start with the hardest ones, I think. Just to clarify, if you can kind of map the AI landscape, right? Because we kind of hear a lot of different words flying around, you know, NLP, machine learning. So there's a lot of things going on into this world. So like, if you can kind of map it out for us, that'd be great. And I will start with maybe Isabel, actually. Yeah.
So you want sort of an overview of what's going on at the moment, or
just like if you can just tell people what AI is at a high level, and then like maybe give a little bit of hint or a little bit of definition around the words that we hear a lot, right? So what is, in your case, what is natural language processing? And if you could explain what machine learning is and where does that sit in the kind of AI world, right?
Sure. So as the name indicates, artificial intelligence tries to build machines that are intelligent. There are different ways of doing that. You can sort of tell the machine what to do. So if you wanted it to prepare a dish, you'd have a recipe and you'd say, you do this. If the pasta is cooked, you take it out, etc. That would be sort of rules-based AI or symbolic AI. And then the other side of things is machine learning. And again, as the name indicates, instead of sort of telling the machine what to do step by step, you give it input data and you give it the output that you expect. So in this case, you'd give it the ingredients on the prepared dish, and you'd be like, okay, you figure out how to do this. And that would be machine learning. Now, another term you might have come across a lot is deep learning. And that is the sort of machine learning on steroids, in that you have between this input and this output, you can have different levels of sophistication. So you can have sort of systems that are going to be fairly simple algorithms, or you can have more involved networks that mimic to a certain extent what you'd find in the brain, even though not completely, and that would be deep learning. And then natural language processing deals with the processing of language, which adds an extra difficulty to the whole process, because machines only understand numbers. So when you give them language data, which is a type of unstructured data, it doesn't come in nice columns, it doesn't come in nice numerical form. You have to find a way of representing this in a numerical form that is appropriate to what you're trying to achieve. And then only can you start applying sort of the usual other machine learning algorithms that you'd want for your downstream tasks. So there's an extra level. I mean, I might be biased. I would probably say that NLP is one of the hardest tasks out there. I mean, there are things that used to be considered very hard, like computer vision, for example, because computers weren't very good at that up until fairly recently. I mean, Tom could definitely probably talk about this much better than I could, but nowadays computer vision has made a lot of progress, and I would call it probably a solved problem to a certain extent. Depends what, but yeah, in general, computers have become very, very good at it. And yeah, I believe that's in general the current landscape of AI and what people are trying to do. So yeah, it's a bit of a buzzword. In reality, it's much more sort of mundane than you'd think, and less glamorous. What people sometimes get confused about is sort of artificial intelligence, as in general artificial intelligence. So creating something that would be akin to human intelligence, and that is not what most people who do AI do.
That's great. Thank you so much for this input, Tom. If you want to add anything, that'd be great as well. If you think that you have anything useful to add to that, because I think it was great. Hopefully everyone kind of had a good kind of view on this at the moment, but please feel free to add anything. Cameron, the same.
Yeah, I don't really have anything much to add. I think that was like a really good explanation. The only thing I would say is that like in machine learning and deep learning, as opposed to AI, you're optimizing something called a loss function, where you're sort of, as Isabel said, like measuring how well you've done at your task. So how well your pasta has been cooked, for example, and then you're using that to assess like how can I improve. But yeah, no, nothing more to add.
Great. Cameron?
Just one super quick thing to add from my side, just because the example of computer vision keeps coming up. Just to give a concrete example of what computer vision actually could be, I think this is quite a common example in machine learning. Basically, if you have a set of images, a set of pictures of, say, cats and dogs, and you want to devise a model which you pass an image of a cat or dog to the model, and it tells you whether it thinks it's actually a cat or dog without knowing the true answer. That's a classic example of computer vision. So stuff like, yeah, image recognition in general is a typical example of computer vision. And like Isabel said, many image classifiers these days are very good. They achieve accuracy of well over 99%, even for difficult images where, you know, a picture may look half like a cat, half like a dog, and maybe the model can do a better job of deciding whether it's a cat or dog than a human could.
Great, thank you.
And typically as well, as Isabel said, like images are numerical. They exist as like pixels on a grid. So comparing it to natural language processing, which half of the problem, probably more than that, is getting it into numerical form.
That's great. Thank you so much. So Erica, I'll start with the juicy one here. So what tools and library do you use on your day-to-day? And what tools would you recommend for any beginners to start into programming and then get into AI? I think I will start with Simon on this one, because you might be doing something a little bit different from the others, but like, what tools do you use in your day-to-day as a quantitative kind of person here, and more on the engineering?
Yeah, sure. So yeah, as you mentioned, so I might have a slightly different answer to the rest, and I'll let the other people answer for more specific AI. But in terms of quantitative analysis and engineering, so Python in general is used more for research purposes, but tends to be more and more used for kind of big applications. So all our applications here are built in Python. And just, you know, this kind of standard libraries that you may have heard of before. So pandas is used extensively. And just to move on from that, so pandas is often used, but also just trying to think of how best to describe this. So what we're doing basically in quantitative and making strategic portfolios is, when you have an investment portfolio, so a bit of context, usually a portfolio manager who's a real human will pick certain stocks he believes will go up, hopefully. and then you as a consumer will buy into that fund. What we're trying to do with strategic and quantitative funds is actually, and of course with the artificial intelligence built in as well, is actually have the computer predict for us the stocks that will rise. And then from that, we'll build a portfolio. Again, using the computer to optimize over these stocks and which ones we should buy and which ones we shouldn't. And so for those kind of things, we use CVXPY, which is an optimization library, SciPy, which some of you may have heard of before. And all of these libraries are very common across investment banks, asset management, things like that, to do this kind of portfolio investment optimization. And so, yeah, a lot of them I think are also used in AI as well. I'll let the others describe there. But yeah, I'd say certainly most banks and institutional investment houses tend to use Python, but there's also other, in my career I've used R, C# as well for more big and scalable products and applications. But yeah, it really depends.
So if one would kind of want to go down that route, what would be for you, or at least the easiest, or the kind of the easiest entry point into just learning how to code?
For me, that would be Python. There are so many examples on the internet for Python. I think other languages are a bit more, so things like C# are a bit more involved. You can only really use it on Windows, for example. But Python is the obvious choice for me. There's so many pre-built libraries. There's so many examples, especially for AI as well. I think any kind of beginner tutorial you find online, or data camp and things like this, will be in Python generally. There's other languages, maybe like R, but I would suggest Python definitely.
Thanks. Tom, Cameron, Isabel, is that the theme as well, Python, or do you have any other language that you think are kind of key there for, especially for the purpose of AI?
I think our CTO would be really angry with us if we suggest that you could do anything from research with Python. But yeah, in effect, it's definitely a good entry point for it, and it's only once you start sort of scaling up your applications and you have you run into major efficiency problems that you'd probably consider switching, or at least like getting something that supports a more sort of solid backend. No. Yeah.
We also use a fair bit of SQL just for querying databases to get data.
Yeah, that's a good point. I think SQL is quite a key one to know, whether you're on the AI side or investment. Certainly, be able to work with data efficiently is really key, I'd suggest.
Great. So yes, like Kimberly mentioned, it's kind of a new area of tech. So could you just kind of let us know how you got into your role respectively? I think Simon kind of touched into it more than the others at the beginning, but maybe Tom, can you kind of restate what you said when you were kind of introducing yourself? And and maybe another question that I find interesting in the same kind of vibe here is like, if you were at another company, what type of like job title could you have, right? Because sometimes you can do something and then it's actually at another company is kind of more kind of known job title, really.
Yeah. So on the first bit, I got into this role through an internship. So yeah, after my PhD, applied to Arabesque AI as an intern, and then worked with Cameron on unsupervised learning. So learning the structure and sort of patterns that are present within our data sets as part of like our research process to sort of generate features. And yeah, worked on that for 3 months. And then took a few weeks off to finish off my PhD, and then joined full time at the beginning of this year. So it was kind of like a a fairly straightforward transition, especially since like a lot of the techniques and stuff were similar to my PhD. And then what was the second part of your question again?
Second part, if you were at another
oh yeah. I think like at least on the research side, you could, if we weren't called like AI researchers or research scientists, we probably would fall under the umbrella of data scientists as well at other firms, or quantitative researchers in if it's finance.
Yeah, sure.
Don't know if others would agree.
Anyone wants to have a go at this question a little bit? Just really, how do you get into your role, basically?
Maybe I have a bit of a more convoluted way of getting into it. While I was doing my PhD, I did intern. That's how I sort of discovered AI, by interning at Microsoft Research, which was also a bit of a strange thing, because for some reason they did need they needed a linguist, not a computational linguist, but an actual linguist, which was very strange. But and that's how I sort of learn about AI. And then I started learning more on the side on my own. And then to sort of, after I finished my PhD, to make the transition, I did a training, not well, it's called a fellowship, where basically they take 2 weeks to teach you about everything. It's actually quite comprehensive, from like making an API. I mean, you don't immediately remember much of it because it's only 2 weeks, but really all aspects of data science. And the idea is sort of to take PhD graduates that might have the transferable skills but haven't been trained as data scientists or AI researchers, and to transition them into data science. And so for 2 weeks they train you, and then after that they pair you with a host company and you do a real world project, hands-on, which is very useful because you can learn about the theory for as long as you want, but unless you actually use it and real world problem, it's not going to help. I mean, you can go on Kaggle and like have those really clean, nice data sets, and this is absolutely nothing like reality. So it's always better to do it sort of hands-on. Yeah, and I did that, and once I finished the 6 weeks of training, I sort of started applying, and I was more confident that I actually had the skills to be a data scientist. Yeah.
Great. Samantha has a question, and she asked if it was difficult to get employed at an AI tech when you didn't come from computer science backgrounds. But I guess in all of your cases, you come with either some sort of doctorate type background and heavily based on kind of statistic, probability, or engineering and finance in the case of Simon. So maybe I can kind of redirect the question is like, how was the interview process? How technical do you need to be? And how comfortable with your coding skill do you have to be really to get into specifically AI and then to get into kind of a tech job?
I might take that one again because I don't come from a quantitative background or engineering or statistics. So yeah, I think it's feasible if you just spend a bit of, like, interviews kind of tend to follow the same pattern in tech. It's that you don't really deviate. I mean, in data science, I guess tech, you have like the coding part, and then data science, you have the sort of data wrangling part. And if you sort of spend a little bit of time doing those kind of coding exercises and data wrangling exercises, then you can go into the interview and sort of not freak out and just be confident that you know what you're doing. So I think even if you don't come from a quantitative background, even if in my case, before I started the faculty training, I had never coded. I had done like maybe a few lines of R during my whole PhD, so it's feasible. It takes a bit of commitment, but it's feasible.
Great. Anyone has, Cameron, do you want to add to that, really, or?
Yeah, sure. Just to add to what Isabel said, like, yeah, your coding skills don't have to be amazing. If as long as you bring something to the table, that's gonna contribute to what we do, then yeah, it doesn't matter if you're not as strong in other areas. So yeah, hypothetically, if you're really good at statistics, but you're not very good at coding, or you're really knowledgeable about linguistics and NLP, or yeah, or you're really knowledgeable in financial markets, yeah, as long as you bring something to the table which we're interested in, then yeah, there's no sort of like expectation to be sufficiently good at everything. Yeah, because ultimately we're a team. We can complement each other's strengths and weaknesses. So it's by no means the end of the world if you're not a master mathematician or whatever.
Right, thank you. Amy asked if you think that an AI could evolve into a being with human-like emotion or soul one day in the near future. Who wants to take that one?
Can I grab this one? as the non-AI researcher. I think it's a really good question.
Yeah.
And it's definitely out there. I think personally that, yeah, one question is, do we need AI to have human-like emotions? Is that potentially a weakness? And is that ever something we would code, for example? Would they ever need those emotions? Would be my question to that. But I think, yes, if you're talking about sentience, definitely. I think one day there will be a scary moment where machines will be more intelligent than us, and there's lots of incentives of you see Elon Musk trying to create kind of boards and things like that of AI ethics and AI safety around that kind of thing, and that's what it's all set up for. Is others. My colleagues may be able to answer this a bit better than me, but yeah, that's certainly what those boards are for. In the case of it's the Terminator films and things like that. But yes, I think is the answer to that.
Yeah, I think we're probably the wrong panel for determining whether it could get a soul or not. But certainly you start to see like scarily human-like levels of question answering response stuff, especially on the NLP side that Isabel could definitely talk more about. But yeah, starting to act like walk like a duck, talk like a duck, we're getting to that point.
Got a cool example. This is a while ago now, but so as part of my degree, I used to do electronic engineering. So we had to make the printed circuit boards. If you ever see like the inside of a computer or something like that, you see all the intricate circuitry and of all the chips and things that's so small, it has to be done by machines and tiny microscopes and things like that. So you couldn't solder these things by hand, basically. So this is all done. This used to be done all manually on a program by a human, but then they made an artificial intelligence machine that linked up all the circuitry and things like that, and it used so the AI machine came up with what looked like a complete mess, and it used like inefficiencies in the board. And a human would have never made this result at all, but the AI was smart enough to use like inefficiencies in the board and the material in the board to actually make a more efficient circuit. So yeah, there's all kinds of things like I'm sure some of you have seen Google Go and yeah, various other things like that, where artificial intelligence is starting to beat the human at things that are very difficult. So.
Mike, I think you're muted.
Cameron, thank you so much, Isabel. Cameron, I have an opinion on this and the evolution of AI and yeah.
Yeah, I'll be honest. It's not something I put a massive amount of thought into. But yeah, like Simon said, it is becoming like scarily good at some things now. But I heard a quote saying that if it is going to surpass human intelligence, it's already too late to stop it. So yeah, if it's going to happen, I don't think there's much we can do about it anymore anyway.
I think it's as Simon was saying, what's going to be hard is to determine consciousness, because it is going to walk like a duck and talk like a duck, but is it thinking like a duck? That's the hard bit, because yeah, machines are probably, if not now, very soon going to pass the Turing test, which is, can you tell that it is a machine that you're interacting with? We're probably there now. Now, does it mean that they have a consciousness? And I'm not even going to touch upon the subject of the soul, because I think that's a very that's going to be a very, very personal thing, whether you believe that consciousness equals soul. But yeah, I think what's going to be hard is determining if it just looks like they do or they actually do.
That's great. So Ruda is interested in you know, on whether or not there's and how to choose a master in AI with like warfare project and important problems that are being solved. She said finding the right supervisor or focusing on deep learning. How did you kind of make your choices for those who kind of went down that route?
I don't think any of us, I might be mistaken, I don't think we did study AI at a university level, or Tom, would you describe what you were doing as physics, or as, yeah, it's hard.
Yeah, mine was kind of a blend, but definitely like it's really, really, really important to gel with your supervisor. So I like in like masters and PhDs, I can't advocate enough for like chatting to them, and also chatting to like their group and the people around them to sort of see if this sort of environment you're going to commit a lot of time to. And I've seen it happen quite a few times where people start a master's or a PhD and then end up not having a particularly great relationship with their supervisor, and it can be very demotivating both for the student and for the academics and the people around them. So yeah, definitely in terms of choosing supervisors, the best thing you can do possibly is meet them and have a coffee with them, and they want to do this as well. They want to be like talking to you and sort of figuring you out as well. So yeah, definitely.
Jeanette is asking, at what level do you need to study to? Level 3, A level, level 4, HNC. I have no idea if those I didn't study in the UK, so I don't know. But please, if you, maybe the question would be, what type of background, other backgrounds do you see among your colleagues and among people in that kind of AI community and investment, actually? Maybe, yeah, maybe Cameron. I know he disappeared. Okay, so he's coming back. So it's going to be
in our team. We have like a very like diverse background of people with different undergrads and masters and PhDs. So I think yeah, as Cam said earlier, it's about the stuff, how we can work together basically, and people have different strengths and weaknesses in different sort of specific areas, but it's about working as a team. I don't know if that answered the question or not.
The majority of our team is PhD level, but that is by no means a requirement. I think we just happen to be a very academically oriented team, and sort of people bringing other people in, and yeah, I have reinforced that.
I think in big tech companies, you generally see a requirement for a master's degree, but that's not exclusive.
Yep. Great. Just a reminder, especially for those who actually joined us, you can ask your question in the chat box, and I can answer those. Kyron, I see just your hands up, and thanks for Ruda for making me aware of this. So we are going to go back into kind of the tool conversation. So Erica is asking if it's worth learning PieTorch or Tensorflow. Tommy's laughing, Isabel.
This is an ongoing debate.
I mean, it depends what you want to do. If you want to do deep learning, yes. If not, no.
Is it one or the other, or either?
So maybe if you can explain what both libraries are doing.
Yeah, so they're both deep learning libraries. So Isabel describing earlier the difference between machine learning and deep learning, and they're both mainly in Python, although they have backends in things like C++. But yeah, I mean, today they are very similar, and like if you know one well, then the other is easy to pick up. But in terms of like something I was going to say earlier, actually, or someone else's questions, like there is this just to shout out to this online MOOC thing called Fast AI, which I found, which is based in PieTorch, which is really, really informative and instructive. So for me, like I learned PieTorch first because it's very similar to things like NumPy, which people often have some familiarity with. But yeah, like they do the same job, so pick your favorite generally.
Do you create your own algorithms, use off-the-shelf solutions, or a combination of both? Maybe Simon actually.
Okay, I can definitely answer that in terms of the portfolio. Don't really. So basically, you'll have a lot of say hedge funds or asset managers who, so especially hedge funds, when they're creating their portfolios, a lot of that is secret source. So a lot of that will be secret. A lot of how they make money. So the better ones will have, better portfolio construction, better algorithms. And, I'm not going to get into it now, but algorithmic trading. So it's a difficult question to answer because everything is their own. And I'd say to some extent, everything is our own. But a lot of it comes from, reading white papers, reading scientific papers and taking bits from there and thinking, okay, this could be applicable for us. Maybe we tune it slightly differently. So it's a bit of both. It's not necessarily that you would, you can do this, you can buy algorithms. And in fact, our whole product is, a user can go onto our web application, select the investments they like, the kind of things they like, and our platform will build them a strategy and an algorithm, so to speak. So you can indeed buy them, but in terms of us internally, most of it is our own, but yeah, influenced by other research and internal research as well.
Thank you so much. Cameron, do you want to add some more from the research side of things, if you can hear me? Maybe there's a delay here for Cameron.
Oh, sorry. Can you hear me?
Yeah.
Yeah. Just to add to what Simon said, yeah, we sort of build our own software, but it's all using open source libraries like the ones Simon mentioned earlier. So pandas, NumPy, SciPy, scikit-learn, TensorFlow, PieTorch, etc., etc. But yeah, from those we build our own stuff.
Thank you. Karen asked us a very interesting question here. Would any one of you have an understanding of how we can make the data that we use in AI more diverse, right? And he said, I imagine that the lack of diversity in the data sets may have an implication in the near future. So maybe you all can talk about the debate that is going on around the way we gather data and how viable is the data that is being used, right, in those kind of programs. Maybe Tom, you want to talk about it a little bit?
Yeah, it's the thing. It's like one of the most important things in AI at the moment is biases in the data sets, and because as things can as use cases ramp up, then like the data you're training on and your model's biases become like unbelievably important when they start to have real world effects. There's like it's very much like an active field of research of how you can best efficiently do this. Like to me, it seems that I guess the problem comes from the fact that big modern models, which are very high performing, require a lot of data. So people tend not to have the desire to go through every example and like label it as in a case by case basis. So people want to get around to doing that, which is the hard bit. So there's lots of automated ways of doing it, but in terms of identifying biases within data sets, yeah, it's like an unbelievably important problem, and it's not a solved one. There are certain kinds of models, as I understand, which are designed to try and measure these things, and there are certain like scores that people have developed for, especially on like text data sets, biases in certain directions. But yeah, like creating big appropriately sized data sets without yeah, like societally damaging biases is you're definitely right to raise it because it's a massive problem, and it has real world effects.
Isabel, do you have?
Yeah, so as Tom was saying, it's a particularly big problem in NLP. So if you don't carefully curate the data that you're feeding to the model, for example, if you're trying to do pronoun resolution, so trying to figure out which is the referent of he, she, etc., there's going to be a huge bias that, you know, if there's a secretary in there, it's going to get linked to she. If there's a doctor, it's going to get linked to he, without any actual good reason for that, apart from sort of statistical bias, which we don't want reflected in our models. So so people have now gone through the trouble of curating these data sets, and it's kind of we're progressing, because now it's a bad look if you don't explicitly say we've removed or as much as we could, we have tried to avoid data bias. People have to do that now, which is a good thing.
Great.
So you need, just to add as well, you need to, like, if you are someone who's using AI, you need to make sure that your use case is appropriate for it. Like things like having some sort of computer vision model to assess, like to help judges make decisions, which was a big thing in the US a few years ago, is just obviously a terrible idea. And yeah, governments and companies need to take responsibility for this sort of stuff, in my opinion.
Yeah, I add to that. Like this kind of stuff for me is really interesting, especially in terms of politics as well. So image and facial recognition is just, you know, I think a lot of times in tech, everybody thinks everything is a great idea, and we kind of don't stop to think about, you know, people's privacy and things like that. You know, there's lots of conversations about privacy, but we're still doing it. And facial recognition for me is a huge one, because, you know, police started using it and all sorts, and there are some cases where, you know, Amazon were using it in their shops without telling customers and things like that. So now people are a lot more clued up on that kind of thing. But I think it's a really important point, and I think it's up to us really, and AI engineers in particular, to think about those things, because I think consumers, it's often hidden away from consumers, and I think it's a really good point by Tom. But yeah, it's a really interesting topic, and it goes into all of that ethics and the boards and should we really be doing those things? And I think especially facial recognition, they've kind of thought maybe this isn't a great idea. And you know, even data training sets on, you know, it was very easy to get before, facial recognition data training sets, but now obviously it should be, and it is difficult to get them now. But yeah, it's a great topic of conversation.
There's a documentary on Netflix called Coded Bias, which is touches on a lot of this stuff as well, which I think is quite interesting.
Yeah, I've watched it. I can agree to that. It's pretty interesting, and there's a book that you can read on as well on the same topic, coming from one of the participants in that program, actually. I have a question a bit more refocused on what you all doing at the moment. How does an investment team work with the researchers in the context of your work? So maybe Simon, so like, what do you expect from the like a research team, and what do you expect from the researcher, and how do you kind of work and communicate? What's the link there? If you do a bit less AI, right?
Yeah, so I'd say there's two levels really. At Arabesque, we try not to have two levels, but it kind of naturally falls that way. So we have the AI research and signal team, and most of the output of that team is generally fantastic research and trying to make a signal. And this is no offense to this wonderful team, but boiled down, it's essentially, you know, your signal is this stock going to go up or is it going to go down, and a rough probability of what we think. So we have many models to try and work that out, and that signal is basically then pumped to my team, which is the portfolio and construction team. So we also have so that's where the quant research starts to come in. So we have this signal, but what do we do with it? How do we make these portfolios? And that's where quant research comes in. And I'd say with quant, it's quite interesting. So it's quantitative research, sorry, I should say. We have research and we have also a lot of engineering. So very similar to AI in the fact that, you know, a lot of the researchers here will spend, who knows, 50% of their time on research, new ideas, 50% maybe engineering, tidying things up, tidying the platforms up, and that can vary. I'm sure they can tell you the kind of split. But for me at the moment, because we've just released our new product, a lot of my time at the moment is engineering, and I would say maybe 20%, certainly in the short term, is open-ended research, and that in investment teams can massively vary. So you might have a pure quantitative researcher who's researching new statistical models for finance and building better portfolios 100% of the time. They're usually the kind of maths wizards that don't want to do anything else, that don't really like coding. And then you get the other side of the scale, which is just quantitative developers and engineering, which sometimes you can be 100% on that as well. And sometimes a bit more like me, you get a bit of a mix, jack of all trades, master of none kind of thing, where, you know, I like the engineering side, but also the research.
Thank you. Cameron, can you give kind of your side of the spectrum, where like, how do you work with an investment team, and what do you think like an investment team will expect from a research team?
Yeah, sure. So yeah, like Simon said, we're very much responsible for delivering these signals to the portfolio team. So I guess let's start with the similarities between what we do and what the investment team does. Like Simon said, because we have this live system which we need to run, we have to put a lot of time into engineering and operations. Ultimately, we're managing millions of dollars in our systems, so we can't really avoid any muck-ups. So we have to spend a lot of time ensuring that our systems are running smoothly on a daily basis. So I'd say probably since I joined 2.5 years ago, I've probably spent, I'd say, at least half of my time on engineering and operations related stuff, or project management related to those two topics. And then the other aspect, the sort of more research aspect, is not just delivering these signals of ultimately whether stock prices will go up or down in the future or not, but the quality of these signals. So, for example, I may be trying to predict whether the stock price of Vodafone is going to go up tomorrow or not, and I can give you some estimate. I don't even need an AI model to do that. I can just look at the stock price and I can give you my own estimate, just that I've guessed. But if that prediction is not very accurate, then we're not going to make money off it. So it's not just a case of delivering these signals in a systematic way smoothly, but also the quality of these predictions is very important. And that's sort of where the research aspect of what we do comes in. We need to make sure that the predictions for these thousands of stocks which we generate every day, that they're as close to being correct as possible. But just going back to the computer vision example, which Isabel and Tom mentioned earlier, like I said, when you're trying to classify pictures of cats and dogs, usually in computer vision these days, the models which do this, they're pretty good. They probably get it right more than 99% of the time. With stock price prediction, it's inherently a much more difficult problem. If we were getting anything close to 99% accuracy in our stock price predictions, I would have retired 2 years ago. Like you would make money so quick, but yeah, you just sort of like almost instantaneously become like the richest person on the planet. So we're definitely not trying to achieve 99% accuracy like in some fields. For us, if we're getting it right more often than we're getting it wrong, then hopefully we'll make money. And so that's sort of our aim.
Thank you. So I saw a lot of time companies saying, you know, we're doing machine learning, we're doing AI, when actually all they're doing is automation. Can someone give just a very simple definition and the difference between the two, right? Isabel, you talked about machine learning when you introduced the topic earlier based on my question. Can you give the difference between automation and machine learning?
Yeah, so it touched upon what I was saying. If you're, and I'm going to go back with my my spaghetti example because I like it. If you're trying to make spaghetti, you can sort of write the rules to make spaghetti explicitly, and then put that in a form which is basically zeros and ones that the computer can understand, and then it can execute it in an automated way. If you're doing machine learning, you don't want to write those rules. You want the computer to figure out the rules by itself. So you want to give it the ingredients and an example of a spaghetti dish that's finished, and just say, okay, now you figure out the rules, or you figure out how to, more specifically, how to weight the ingredients and how much importance you give it to each ingredient, and how you combine them to end up with the end product, and it's basically going to be based on statistical models of various kinds. I don't know if I did a good job there, and Tom.
No, I don't have anything more to add.
I think usually you're doing a good job at just going straight to the point, Isabel. So thank you so much for that.
I'm gonna hope that's a compliment. I'll take it as.
If you have questions for the panelists, please put them in the chat box. That would be great. So Arabesque, can you talk to us a little bit more about the internship program, maybe? Tom, you just said that you just been through it, so maybe you can touch a little bit on it.
Yeah. So the way we tend to operate it is that an intern will have like at least I can speak for doing a research internship. They will tend to have a like a research project which they're doing, like a sort of new model they're evaluating, or like a new feature that we can use to predict things. And then they'll work on that for 3 months, sort of 80 or above % focused on this. So that's the way we tend to operate internships. I don't know if Sophia, you would like to say anything more about this.
Yeah, sure. I can speak on like logistics. We are currently taking applications for our AI research intern program until December 31st, but applications are looked at on a rolling basis. And you don't need any sort of coding experience or anything like any sort of crazy qualifications. You don't have to have your PhD. I mean, we do tend to hire PhD level candidates, but you could even have like masters, or really just we want anyone to apply. So don't be like scared off by all of their crazy PhD titles here on the call. We really are just looking for people who have interesting ideas and want to share them with us. So yeah.
Thank you so much. Can you talk about maybe a little bit more the kind of pure kind of coding? And when I say pure coding, it's like software engineering side of things. Like, are they using also just Python in general, or are they using other kind of technologies? Maybe Simon?
Yeah, sure. So we basically have split into 3 teams. We don't usually like saying this, but at the moment it's kind of AI, artificial intelligence team, the portfolio construction team, quant research, and the web app. I think the web app's built in React, but I'm not too knowledgeable about web app development. But certainly the portfolio construction side, I've done this for various institutions, financial institutions, and most of the time it's been Python, so purely Python. And the databases are various. So at the moment, we use PSQL, and we're looking to change that. But indeed, as Tom mentioned before, so SQL is kind of key in certainly in artificial intelligence and in finance as well. One of the things that got me into finance, actually, and as sad as this is, was just the sheer amount of data available in finance, and the way it lends itself to these kind of problems is there's not many other industries like it. So yeah, I'd say Python for us definitely underpins most things. And that's for our applications. For research, like I said before, so a lot of the research I've done is in Python or in R. It just depends which people are comfortable with. I've done research in MATLAB as well. So research for me, certainly in the quant space, has tended to be a bit more flexible. So you kind of pick which one you're comfortable with. But when you're building production applications, it's more, there's more decisions involved in that in terms of stability and so I've written applications in C# as well. So yeah, some of it depends on what the institution you're working for has been used to before, and what other people have skills in, and some of it's decisions in what's the best tool for the job. But yeah.
Just to add on the engineering stuff.
Sorry.
Oh, you go. No, go.
No, I was thinking maybe we should mention the cloud infrastructure as well, but if that's what you were going to do.
I was going to say the Git is the other thing we use quite a lot. So it's something you can definitely have on your own local computer and get familiar with. But yeah, cloud as well. Do you want to get on that?
Yeah, so for when you're scaling applications nowadays, it's very quickly you won't be able to run things locally. So we use cloud storage, and we use cloud computing resources to be able to scale the applications and actually perform the computations.
It's actually a really great example because that's something I found very difficult coming from. So when I did my master's, all my coding was alone. You know, I did my dissertation coding alone. My code was probably disgusting, but nobody saw it, so that's fine. There's no testing or anything like that. But yeah, it's a great point because when you come and work in big teams, you need to use Git pretty much every day. You need to get comfortable with working with other people. You need to get comfortable with, you know, merging code and things like that, and testing. And as Isabel said, yeah, cloud infrastructure and scalability is hugely important. So our application is already running thousands of strategies every day, and the sheer amount of data we get through. And I'm sure the AI team can talk about, you know, cost and the amount of data needed for training the models, and you know, we can only really train the model, I think it's once a month, right? Maybe even quarter, just because of the sheer amount of data and things like that. But yeah, there's lots of different things you have to get used to quite quickly, and that's something I found actually very difficult when I started working in a team, was yeah, scalability and things like Git, tools that you never used before. But yeah, it's a great point.
Especially on the cloud stuff, like you wouldn't be expected to know that going in. Like this is like stuff that people tend to learn on the job, I think.
Samantha has a question on, so how do you see AI integrating more into the workplace? Do you see any potential for AI causing a wide loss of jobs due to automations? What do you do with those lower skilled educated workers that have lost a job? Again, like on the opinionated question, so please feel free to voice your opinion on the topic and what you see coming at least. Cameron, do you want to have a go?
Yeah, I mean, the way I think of it is, I mean, yeah, this is my personal opinion of this. I'm quite biased, but to me, it's just a reshifting of skills. Like, yeah, as humans advance, they'll just have to become more comfortable with working with technology and maybe less comfortable with the skills required, which the technology is replacing. Yeah, that's sort of my naive interpretation. And I think these things have to equilibrate to some extent. Like there has to be some government intervention or something. Like it can't be just the extreme hypothetical scenario of just one person has a job devising some algorithm which does everything and everyone else doesn't have a job. Like, yeah, there has to be some equilibrium state which is economically and sort of like politically even loosely feasible. Yeah, that's my opinion.
I think this isn't a new, like technology advancing is a new thing. So I think AI is just going to become like telephones or computers, something that everyone uses, everyone knows how to use. And actually, I think initiatives like the faster we get to the point where everyone is comfortable using it, the better. And then it's, I mean, yeah, maybe telephones and, you know, telephones have replaced people who did the telegraph, and computers have replaced other jobs, but there's always been a sort of smooth transition to just, it is also creating different jobs at the same time. So I don't think that's going to be an issue.
Simon, do you want to talk about it a little bit, or?
Yeah, I love these open-ended questions. I personally think there's going to be a bit of a struggle with the transition. So I think Cam's right. I think in general it'll just be a move to different skills. But you've got things like universal basic income, which I think is going to be necessary potentially in the future. So that's where everybody's given a certain amount of income. But it's not even AI really. AI is part of it, but if you think of like self-checkouts in Tesco. There's nothing AI in that, it's just automation. But you know, the other side of the argument is this has been happening since the Industrial Revolution, so we've been through all of it before. But yeah, as I said, I think Cameron's right. Like there's going to be a general shift towards more tech, and that's already happened. But yeah, I am a little bit worried about things that are ripe for the picking, like taxi drivers, for example. You know, Uber and Google and whoever else is looking into autonomous cars and what happens with that switch, and you know, can we move those people and retrain them fast enough? So I think there's going to be a big switch, and I think some people are going to struggle. Another good example is the tube. You know, if you take the DLR in London, that's already automatic. So why not make all the other tubes automatic? So there's political reasons behind this. There's, you know, I'm sure there's lots of things we could make autonomous already, but for certain reasons we don't want to. So yeah, I think it's a good question, and there's lots of variables towards it. But yeah, I think it's going to get a little bit uncomfortable for certainly in the next 20 years for certain industries, and other industries are gonna reap the rewards. But yeah.
Thank you all.
Don't get into translation just now.
All right. Maybe I have like one last question for each of you. Isabel, how many languages do you speak?
Sorry. Oh wow. Is it because I'm a linguist?
I'm just asking. Yeah, maybe.
I speak fluent English, French, and French is my native language. I speak fluent English and Spanish, and can get by in Italian, Dutch, and Portuguese.
Oh, okay. Thank you. Impressive. Tom, what is the most interesting thing in AI for you at the moment?
I don't really know. I think the most interesting thing is probably the thing that's going to most likely change the world, which is these massive language models that you see, such as GPT-3, which can do these things that we were referring to earlier about like answering questions and passing Turing tests, and the ability that they have to move between different tasks with very little prompting is terrifying. So I think this is something definitely to watch.
Thank you. And maybe for Simon and Cameron, do you think that AI and financial data are kind of a match made in heaven, or are they kind of more interesting kind of scenes where you can kind of apply AI? Go ahead.
First, for me, yeah, it's match made in heaven. So I did engineering at uni, and I kind of fell into software really just by picking certain modules and loved it. And ever since then, you know, for my dissertation, I did data mining and things like that. And I just almost fell into finance just through the sheer amount of data and the sheer amount of availability, and applying all these models, and it just works. And you know, it lends itself to the industry as well. You know, there's plenty of engineering sectors that also have interesting AI problems, but for me, finance is a really obvious one. And I think if you go and have a look at some of the AI examples, even for beginners, you'll see lots of them are finance based, and that's enough to tell you that there's lots of interesting examples out there.
Cameron, do you want to add to it?
Yeah, sure. Yeah, I think there's definitely a lot of compatibilities. I think just one thing I would say is, yeah, people working in finance, they like to stay state of the art. So like, if an opportunity comes up where AI is like easily applicable to improve their processes, everyone will do it, and then that opportunity will disappear. So it's like a constantly evolving process of trying to stay ahead of your peers. otherwise, yeah, the opportunities sort of get arbitraged away. But yeah, I guess that's what makes it fun, keeps you on your toes, and yeah, keeps you eager to keep improving.
Thank you. Isabel, I have a last question for you in terms of NLP, and maybe because I feel like it's maybe an area where people have less kind of knowledge. They hear the term a lot, but maybe have less kind of knowledge. Do you have any kind of like entry point in terms of, I don't know, website or anything, or resources that people can kind of start looking into it a little bit, that is kind of not too hard to get into?
Yeah, if you really want to sort of beginners level courses that touch on the high level of things, I'd say DataCamp isn't bad. You can very quickly learn how to do things in GenSim, NLTK, etc., in those NLP libraries. And then maybe once you sort of got a few things working, you'll want to look at, like, dive deeper and look into how you would write those from scratch and look into the theory. But it's a good entry point, I would say. Yeah, can probably share I'll share the link.
Thank you so much. Is anyone having another question? Because we're getting close to the end. So before wrapping up, just making sure that no one has missed a chance to ask a question to our panelist. Thank you all so much for sharing all your knowledge, and then everyone who shared the link for any topic. I think there's from Kaggle to DataCamp to Git, anything has been shared. So thank you so much again.
Thank you very much for organizing.
Thank you.
Thanks.
Yeah, thanks everyone. Thanks for the great questions.